So it says, first of all, if there's a line that is parallel, I'm going to make the parallel symbol instead of writing parallel. So we have a line that's parallel to one side of the triangle, and it crosses the other two sides or touches the other two sides. Then it divides the sides and intersects them proportionally. So it causes the nested triangle. The nested triangle, we've talked about it a little bit, how there's a triangle inside of a big triangle. We've already talked about that. That's true. That's what that's talking about. But what happens is, as long as the lines are parallel, like right here, the little arrows mean parallel, then the sides are also proportional. We've not really talked about that, but the side here is proportional to this side. And this side is proportional to this side. So not only can we compare the sides of a triangle, we can also compare the little parts where they divide it if the lines are parallel. Okay, so I'll show you what that means as we do some problems. So the first example wants us just to figure out what the proportions are. So we're just comparing the things that correspond together. So the first one says ID and then IV, and it says it goes with D. So what proportionally does that match up to be?
EO.
EO. Good. Okay. Next it says ID, and then it says DV, and it goes with DE, and then what proportionally would it match up with? DO. Okay. Any questions? Okay. Next one's a strange, crazy picture, but same thing applies. All three of those lines are parallel, so all those little parts are proportional to each other. Okay. So it says AY, and then it says LA. So YE, and then what goes with that? Okay. We're going to cross off this one. Those letters are not right, so don't even worry about that one. Okay, the one underneath it says LY and PL. And then it says what goes with RS. Yep. So you're just matching it up on the other side. You're just making it look the same on the other side. So YR or RY. Okay, try that last one by yourself. So let's look at it. Let's see. We have PA, ES, so AY, and then, yes, EY will go with that. Okay. All right, let's look at some problems where you're not just matching up what corresponds, but problems that you can actually do with this. So the first example there, let's say that it's hard to see where that X is supposed to be, but it's supposed to be right there. Okay? And what this is telling me, it's called the triangle proportionality theorem. That's what this whole thing is meaning. But what it tells me is I don't have to worry about the whole sides, but I can just divide. So I can do 32, and the thing it matches up with is 40, and then 24 over X. So I can divide the sides proportionally, and then I can solve. So go ahead. How would you solve that? Cross multiply. So 32X equals, and then I'm going to do 24 times 40. I think it's 560. Is that right? Okay, what is it? I'm sorry, what?
960.
Okay, and then divide by 32. What do you get when you divide? What? 30? Right. Try the next one by yourself. Alright, so if I match this one up, I would have 8 over 10 equals 5 over x. You might have had it written a different way, but I think you're probably going to get the same answer. When you cross multiply, you get 8x equals 50. Divide by 8, and you get 7.5, I believe. 6.5. Oh, what? Sorry.
6.25.
Okay, never mind. 6.25. Any questions about what I did?
Oh, never mind, I know what it is. I just set it up wrong.
Right. The last one is a little different than the other two. And the thing that's different is that they gave us the base. Like they gave us the 8 and the 20. And although it seems easy enough just to match up the 5 and the 8 and the x and the 20, it doesn't work that way. Okay? The only time it doesn't work is when they give us the base of the triangles. Okay? If they give us the sides, then you can match up each little part just like we did on the first two examples. Okay, but on that last one, I have to do it differently. And what I have to do is I have to think of the fact that there's a little triangle and there's a big triangle. And we've sort of already talked about problems like this, but I just want to remind you how it's different from those first two examples. So when I think about the little triangle, I can start with the 5 on the side of the little triangle. But what's the side on the big triangle? Nope. See, x is only part of that big triangle.
5 plus x.
5 plus x would be that whole side. Okay? And then when I do the other two sides, 8 is of the little triangle, and then 20 is of the big triangle. So, you see how that's different from these two right here? I didn't have to look at the whole side when I did these two because I was looking at parts of the sides. But here, because I had 8 and 20, and that was the bases, I had to do the whole thing and then the little thing, looking at the little triangle and the big triangle. Okay? Alright, so then we cross multiply. Don't forget when you multiply that the 8 multiplies by both things. 5 times 20. Okay. Subtract 40 on both sides.
60.
Divide by 8. I think that's maybe the 7.5.
Yeah.
Alright, there's some other things that you can do with similar triangles. We've talked about angle bisectors before. And when you have an angle bisector, what it does is it splits the angle into two. If it's a perpendicular bisector, these two parts would be equal. Okay? But what this is telling us is if it is a angle bisector and not a perpendicular bisector, that the sides are proportional to the other two sides of the triangle. So again, proportional is our word here. That's our word when we talk about similarity. So what that's meaning is that the side of the triangle, they are proportional to these sides of the triangle, as long as it's an angle bisector. And I can tell here that it's an angle bisector because it has these little marks, and that means those two angles are the same. So if those two angles are the same, then the sides beside of it and away from it, those are proportional to each other.
Wait, wouldn't you set up like 10 plus x plus 2 equals 14 plus 2x plus 1?
You're going to set it as fractions. So
Over x.
10 over x plus 2,
Oh, 2.
and then 14 over 2x plus 1. Or you could do 10 over 14 and x plus 2 over 2x plus 1, whichever way makes sense there. Okay. So let's solve that. We're going to cross multiply, so that would be 20x plus 10, and then 14x plus 20, 28. All right, we're going to subtract 14x on both sides, and subtract 10, and then divide by 3. 6, and you get 3. Alright, so there's how you set it up, and then you get 3. So that's when you have an angle bisector that makes those sides proportional. Okay? And the last thing that it says that we can do with similar triangles is that we can find the missing coordinates using similar triangles. So if I look at this first example, I can see that this is at 0, 2, and this is at 3, 0. Okay? And at this point, the C point is at 0, 4. So what did I do to the A point to get to the C point?
You went down to,
From A to C, I multiplied by 2, right?
oh, A to C,
Multiplied by 2.
yeah.
Okay? So same thing has to happen from B to D. So I multiply by 2, and so what do I get for my answer?
6 0.
Yep. Okay, try number 9, example 9. So to go from 6 to 15, you're multiplying by 2.5.
Yeah.
Yeah.
Okay, and so that means that you got to multiply the 10 by 2.5. Is it 25?